So for this question that we got here is a patient who requires to get an infusion of dextrose 1,000 milliliters or just 1 liter to be infused over 8 hours using a standard giving set which got a macro drip rate of 20 drops per mil, and the question requires you to calculate the drip rates in drops per minute. That's what's required. So they need to be drops per minute. So in this question, we don't have the volumetric pump. We don't have the pump that we need to use. So in other words, if you're to look at this question here, we're just using a gravity-fed infusion set. So what we could do for this question is we could start breaking down our question, and we can technically say that for sure this one will be the volume. That's what we need to know, because it's always good to break down what you've been given. And then we got 8 hours here, which will be your time. And then we got 20 drops per mil, and this becomes your drop factor. There are two drop factors, by the way. It's either 20 drops per mil or 60 drops per mil. When we use the 20 drops per mil, that means it's a macro drip, the one that we call a macro drip. So it's giving you big drops, and this one will be used for dots. When we got another giving set, which is just giving us 60 drops per mil, that means we are getting small drops coming through, but so many of them. And this technically is for the babies because they got smaller blood vessels in that sense, or they got smaller veins. So you need to give so many drops just to make 1 milliliter. So for this case scenario, we got 20 drops per minute. We got 20 drops per minute, so for sure this one will be for an adult because the veins are quite big, so they can have those big drops coming through. Just 20 of them will make 1 mil. So what we'll do again now here, we can come and work through this and talk about the formula. The formula that we normally use for this one, again, it's rate. And rate to me is like more, again, it's more like a speed at which you'll be infusing this fluid. So when I talk about speed, sometimes again I tend to go back and talk about the speed that you drive your car. It's kilometers per hour. This one, the speed that will infuse this dextrose, it will be in drops per minute. So this question will be asking us, because here we got drops per minute, that your rate should be drops per minute. Or you might see some just books using what we call DPM, which is the same thing, or the DPM, or this will be used. You'll see them in the books. So it's the same thing, just means drops per minute. So we got drops per minute, and that's why we tend to use the DPM. So the formula is equal to volume over time. And remember, the volume always needs to be in milliliters when you're doing these calculations. And your time needs to be in minutes. Then you multiply this by the drop factor that we already got. So in other words, we can just say, rate, which is in DPMs, is equal to volume over time. That's the T for time. And then times, and the volume here, we could say it's in milliliters. This one needs to be in minutes, times the DF, your drop factor. So because we got our question there at the top, for sure we got our volume. We know for sure the volume that we got is 1,000 milliliters. Then we got the time, which is 8 hours. Remember, this needs to be changed to minutes. And then we got our DF, which is 20 drops per mil. And that's what we got. So if I was to come back here and just all this information, feed it into this formula, I should be able to finish this. What I mean is the volume will go there, and the time should come here, and this needs to be in minutes, by the way. And then your drop factor should come there, and you should be able to calculate this question and get your answer. So in other words, we can just say the rate. We could just come and say the rate in DPMs is equal to the volume that we got there, which is 1,000 milliliters. You divide this by time, which is 8 hours. But remember, because it's 8 hours, we need to multiply this by 60 minutes, because 1 hour we got 60 minutes. So in 8 hours, how many minutes are there? So we need to multiply this by 60 minutes just to change the hours into minutes. And then here you have to multiply this by your drop factor, which is 20. So again, if you choose to use your calculators, it's okay, but either way, you should be able to get the answer. You can divide 2 by 2. Here is 1. Here we'll get a 3. And then if you're to divide this, and there are 1,000 of them here, you end up with your answer as 41.66667. And then we'll round up this, because what I mean by rounding up is from the decimal point here to this 666 here being more than a 5, we'll round up. If it was to be below a 5, like a 4, it will just be rounding down and it will be a 0. But this one being more than 5, we round up. That means we'll say plus a 1 here, which now this one will give us our answer as 42 drops per minute. And that's what's required for this question.